Hello, are you a chemistry student in Alberta or somewhere else in the world and you are learning how to calculate the pH of acids and bases for both strong versus weak acids and bases? Well, my name is Miss Simpson and here's a quick shortened video that's showing you again how to do your calculations based on an acid-base chart where you are given the formula for acids, the name of the acids and the formula for them on the left, and then the formula for the conjugate base of those acids on the right, and the Ka values for the acids. Well, your top 6 acids on the chart are known as strong acids. They don't even have a Ka value because they are 100% ionizing. So what that means is if you're trying to find the concentration of the hydronium ion and you have a strong acid, it is the concentration. But if you have an acid below the hydronium ion on this chart, these are all your weak acids. Their Ka values are all less than 1. In order to find the hydronium ion concentration, you need to take the Ka value, multiply by the concentration of the weak acid that you're given in the question, and then square root it. And that will give you your hydronium ions. Now, what if you have a base on the other hand? Bases are going to give you hydroxide ions. Now, the only strong bases that exist are ionic hydroxides. So something like sodium hydroxide or calcium hydroxide, okay? So the hydroxide ion is the only strong base. To find the concentration of those ions, the hydroxide ions from the base, you take X times the concentration of the strong base, X being the number of hydroxide ions in the compound. If, on the other hand, you have one of these bases that are above the hydroxide ion, these are the weak bases. The weak bases, you're going to find hydroxide ions similar to how you found hydronium for a weak acid, but you need to use the Kb value, and the Kb values are not given on the data booklet, only Ka is. So you're going to have to find Kb by taking Kw, which is 1.0 times 10 to the negative 14, and dividing by the Ka of the conjugate acid of that base. So for example, if you're looking at SO4 2- and you're trying to find its Kb, you're going to take Kw and divide by 1.0 times 10 to the negative 2. Okay, now just a note that if you have the conjugate base of one of the strong acids, they are weaker than even water is on the data booklet. And we know water is neutral. So those anions are nothing, but every other anion on the chart and ammonia are all weak bases with the exception of hydroxide being a strong base. Now, once you have the concentration of these ions, these are the formulas that you're going to use. Okay, if you're trying to find pH, you're going to take the negative log of the hydronium ions. If you have hydroxide ions and you take the negative log, you're going to get a number on the pOH scale, but you could easily subtract it from 14 to get the pH from the pOH. We also have the Kb formula and the Ka formula rearranged to solve for those values and percent ionization. I hope this video was a quick overview on how to do pH and pOH calculations. Thank you for watching. Please like and subscribe.